All right, in this video, we're going to conclude our discussion about intercept form of a function, quadratic function. So remember that a intercept form of a quadratic function looks like this. Y is equal to a times x minus p times x minus q. And you might say to yourself, well, what if my parentheses actually look like x plus a value, x plus 5? Well, that's just a negative in disguise because that's really x minus a negative 5, which makes it x plus 5. Okay, and so in this case, our p-value would be negative 5. And you might say to yourself, well, what if there's nothing in front of my parentheses? There's nothing there. Well, that's just a 1 in disguise as well. Okay, and so we can look at the function above and know that this is going to be 1, and this is really x minus negative 2 in disguise. So that makes it easy to find our x-intercepts. Our x-intercepts are what are we subtracting, and in the first case we are subtracting negative 2. In the second case we are subtracting positive 2. So let's plot those on our graph. And then let's plot our axis of symmetry, which is going to be right smack dab in the middle of those 2 points. And that's going to be at x equals 0. X equals 0 is also the x value of the vertex. And in order to find the y value of the vertex, we're going to take that 0 and substitute it back into the formula. So y is equal to 0 plus 2 times 0 minus 2. Take a second and do that calculation. 0 plus 2 is 2. 0 minus 2 is negative 2. So here we have 2 times negative 2, which is negative 4. All right, so down here. And then we can use the fact that a is equal to 1, right, to get a coordinate to the left and to the right, going over 1 and up 1. And now I have enough of an outline of my function to draw my handy-dandy parabola. Of course, the y-intercept is the same as the vertex, right, because the y-intercept has a x value of 0. All right, hopefully you remember that our domain will be from negative infinity to positive infinity. Looking at this graph, our range will be from negative 4 to positive infinity. Our interval of increase and decrease, well, look at the graph. It cuts, the axis of symmetry is cutting that graph right down the middle. The left half of the graph is going to be negative infinity to 0. Right side will be from 0 to positive infinity. Left side is decreasing while the right side is increasing. So our interval of increase will be from 0 to infinity, and our interval of decrease will be from negative infinity to 0. There we go. All right, next example is this one here. This one, we have to actually write the equation if we're given the graph. So we're going to take a look at our graph. We are going to identify the intercepts. You see we have one intercept here at negative 2. The other intercept here is at 3. So our p value and our q value are negative 2 and 3. And then we need one more point on the graph. And that's going to be that this xy coordinate. It could be any coordinate on the graph besides the intercepts. We're going to put our x value of 2 and our y value of negative 12. Now we need to actually find out what a is. Because remember, our function is going to be written y is equal to a times x minus p times x minus q when we're writing intercept form. All right. So we're going to take and put everything into this formula that we just collected. The only thing that's not going in is a, because that's what we're trying to find. So let's put everything together. Y is negative 12 is equal to a times x, which is 2, minus p, which is minus negative 2, also known as plus 2. And then multiply that by x, which is 2, minus q, which is 3. All right, let's clean up the right-hand side. This 2 times 2 is 4. This 2 times negative 3 is negative 1. That whole thing is multiplied by a, and that's equal to negative 12. 4 times negative 1, that's negative 4a. Is equal to negative 12. And then if I divide out my negative 4 on both sides, we end up with a is equal to positive 3. So now we're going to go back and put in values for a, for p, and for q. So we'll end up with y is equal to a, which is 3, x plus 2, because it's minus negative 2, and x minus 3. And that will be my equation. Going to do one more like that and give you a chance. All right. Same idea here. Identify your p, q, x, and y. P and q are 2 and 4. X and y is going to be 0, negative 4. Remembering my function, y is equal to a times x minus p times x minus q. Plug in everything except for a, so y is negative 4 equals, keep that a. X is 0 minus p, and x is 0 minus q. All right, so we get negative 4 is equal to a times negative 2 times negative 4. Negative 2 times negative 4, I think, is 8, right? So 8a equals negative 4, and we'll divide out the 8. And we'll get a is equal to negative 4 over 8, which is the same as negative 1 over 2. And we're ready to put our equation together. Y is equal to negative 1/2 times x minus p, which is 2, and x minus q, which is 4. All right, use this to model and do the next one on your own. Here we go. P is negative 5. Q is positive 2. X is negative 4. Y is negative 2. So that means negative 2 is equal to a times negative 4 minus negative 5 times negative 4 minus 2. This is positive, so we have 1 times negative 6 times a is equal to negative 2, or negative 6a is equal to negative 2. A then would be 1/3. Our equation will be y is equal to 1/3 x plus 5 and x minus 2. All right, I'll catch you on the flip side.